Now we're going to consider some graphs of other functions. Specifically, right now we're going to look at the tangent function. And in a moment, we're going to consider horizontal dilations of that tangent function. But before we do, I think it's helpful that we look at the properties of the tangent function on our coordinate plane. So our domain, we see here that x is an element of all real numbers, except that x cannot equal pi over 2 or any multiple of pi, provided that we're talking about integers. Now, let's think back a little bit about that unit circle, and if we define the tangent function, so the tangent is equal to the sine over the cosine, and at pi over 2, back on that unit circle, well, the cosine is 0, and at 3 pi over 2, the cosine is 0. So that's undefined, and therefore it creates an asymptote. And we can see that we got an asymptote here at, let's say, negative 3 pi over 2, and negative pi over 2, and positive pi over 2, and positive 3 pi over 2. So every multiple of pi over 2, we're going to see a asymptote. Not every multiple, I guess. Anyway, at pi over 2 and 3 pi over 2, positive, negative, and then multiples of that, we've got an asymptote. So our range, though, is going from negative infinity to infinity. We've got y-intercepts at pi, and at 0, and at pi, and if it goes on out, 2 pi. We got a y-intercept at 0. We've got infinite discontinuity at pi over 2. Obviously, we've got our asymptotes. Symmetry, it's an odd function, so we've got symmetry over the origin. We can rotate these 180 degrees. We got symmetry. We have no extrema. And our end behavior, the limit of tangent of x as x approaches negative infinity, and the limit of the tangent of x as x approaches infinity, well, it does not exist because we cannot have the same value. And so the function oscillates between negative infinity and infinity. Now, let's take a look at some horizontal dilations of this tangent function. Now, in this case, we're asked to, we graphed y equals the tangent of 4x. Now, I did some adjustments to my window settings because it can get really busy if you just use the zoom 7 trig function to see this. This tangent of 4x gets really busy. And I set here, as you might can see, that I set an x minimum at negative pi over 2. I set an x max at pi, and I did an x scale of pi over 4. So every one of these tick marks here, from here to here, is, let me put a different color, from here to here and to here, each one of those tick marks represents pi over 4. Now, algebraically, we can determine our vertical asymptotes by taking the basic equation, bx plus c equals negative pi, and bx plus c equals positive pi. In other words, we start at asymptotes at pi over 2, negative pi over 2, pi over 2, and in this case, b is equal to 4. So we got 4x, and of course we don't have any c equals, and we're talking about vertical asymptotes here. Well, let's see if it equals negative pi over 2. And if I divide both sides of this equation by 4, which is the same as multiplying by 1/4, then we're going to have a vertical asymptote. One of these would appear at negative pi over 8, and then I'm going to see another one multiplying again by 1/4 at pi over 8. And when I look at this graph, if these tick marks represent pi over 4, well, halfway between there, I'm seeing vertical asymptotes. And so that represents the pi over negative. This one represents negative pi over 8. This one is positive pi over 8. And I see one every pi over 8. Halfway between my scale of pi over 4. That's why I set my scale at pi over 4. All right, well, let's look at another one. The horizontal dilation. This time we've got y equals the tangent of 1/2 x, let's say, or x over 2. Now in this case, this time I set my x minimum at negative 3 pi, my x max at 3 pi, and I did an x scale of pi. Now why did I do that? Well, I'm anticipating what's going to happen to my asymptotes. So if my vertical asymptotes could equal bx plus c equals negative pi over 2, and if I substitute in 1/2 for b, and in this case we have no c, so I'm just going to leave it off. Well, now I'm multiplying by, or if I divide everything by 1/2, that's the same as multiplying by 2. And so I should see a vertical asymptote at negative pi. And over here on my positive side, again, I've got 1/2 x. And if I multiply that by 2, well, that's 2 pi over, I guess I should do it like this, 2 pi over 2, those cancel, and I've got a vertical asymptote at pi. So if my x scale is sitting here at pi, so from here to here is pi, well, I see a vertical asymptote coming right here at pi. I see another one at pi on this side. And Shazam, there we go. So we see horizontal dilations of that tangent function. Next, we'll look at reflections and even maybe some phase shifts. It's going to get really crazy.